Welcome to April 21st LeetCode Challenge. Design hash set. Design a hash set without using any built-in hash table libraries. So those would be including sets, dictionaries, and stuff like that. Implement my hash set class, which has a method add, which inserts a value key into the hash set. Has a method contains, which returns whether the value key exists in the hash set or not. And then we have the method removes, which removes the key in the hash set. If the key does not exist, then the hash set do nothing. So for this example, we call the method my hash set. We call add on 1, which adds 1 to the set. We call add on 2, which adds 2 to the set. We call contains on 1, the answer is true because we have 1 in our set. Contains 3, the answer is false because 3 is not in our set. We add 2 to it. So the property of a hash set is that it contains only one, the keys are unique, so there's only contains one value, one unique key. And then so therefore it does not change the size of the set. Return call contains on 2, the answer is true because we do have a 2 in there. We remove 2, so therefore leaving 1 left in the hash set. And then we call contains 2, which returns false because 2 is removed. So the constraints are between the keys between 0 to 10 to the 6, and most 10 to the 4 calls can be made to add, remove, and contains. So we can't use built-in classes such as sets and dictionaries. There's kind of two other approaches we could do, but intuition kind of tells us basically this is an easy problem, saying basically go back to basics and design hash set method. So we could just basically make like a replica of a built-in set, basically of what they use in Python. So the information would be similar to the original as well. So we only need to implement a simplistic version of a hash set. Simply input the values like a string between the integers given, right? So we know that the key itself is going to be 0 to 10 to the 6, so we can use that to our advantage to kind of rebuild a more simple hash set reconstruction. So we can use a list, but to reconstruct a hash set, but if we already know our constraints here, this is actually another method to go about doing that. Alright, let's just go with the easy route and define, just go with the regular hash set. So first thing we need to do is define a bucket list. And that's going to hold a our bucket list size. It could be any number. I'm just calling it that. Usually it's prime number? No, not prime number. Yeah, prime number. Self dot hash set will be an array of array. So list comprehension for blank and range of our self dot bucket lists. A bucket size, just to say. Size. Let's kind of erase this. So we list basically of the bucket size into buckets. That's typically how we call the hash set place slots, I should say. The next thing you want to do is be able to add a value to it. So in order to add something to the value, so we need to make sure that it satisfies the set. So if not contained, self dot contains key. So notice how I'm calling this function here. So we need to check whether the value is already inside the set or not. And then we add the appropriate key. Well, so basically the only tough part is this contains method, I would believe. But we'll deal with that when we come to it. Self dot so we need to take basically define a value called current or cur, append a key to it. So add the key to the appropriate bucket, appropriate location. If now next thing we're going to do is remove it. So if we can only remove it if it contains it, if self contains the key, then we want to self.remove the current bucket item. Remove key. So remove the key from the appropriate bucket. Alright. So how do we check to see if a key is located inside this hash set or not? So we define a self.current, so it'll be the current item in the bucket or current location space. And we need to take the hash set, and then we need to find whether the key exists in the hash set or not. So to do that, we want to take the key, take the modulus with the bucket list, self.bucket list, bucket size I should say. So key modulus bucket size is just basically a hash function, right? It just basically tells we take a hash function. It's not a complicated one, but it's one of the simpler ones. And then we want to basically because we define self.curve as a static variable to represent the current bucket item in that list, so that we want to basically be able to return a boolean here. So return of the key in self.cur, which is going to return a boolean. So this is basically a simple reconstruction of a hash set. Thankfully, like, hash functions are usually more complicated, and hopefully this will work. Alright, accepted. So I think this is the stereotypical answer that they were looking for, hopefully. Yeah, it's just basically an algorithm's interpretation of a hash set. Alright, that was fun. Have a great day, guys.